what this is about is thinking about how we match up different spatial scales of human decision making from the street level, where people have visual perceptual information and they can use that to make decisions that they enact pretty much immediately, to the neighbourhood level, where people are relying on cognitive representations of space, and the decisions they're making will be enacted in the future when they arrive at that point at the street level. So I think Construal level theory, which comes from the psychology literature, can give us a nice framework for thinking about these decisions. Construal level theory says that decision construals, or how a choice is set up, depends on the decision maker's psychological distance from the object of decision making. So to give an example, participants were asked to describe locking a door, and they were asked to describe the doors either placed in the same city as the participant or a different city. And in the case with the same city, people preferred to describe it in terms of putting a key into a lock, which is a more detailed, less abstract representation of that action. But in a different city, people preferred the term securing the house. So this is a more abstract, high-level, goal-orientated construction of the decision. And we can see there's a spatial element here. So a larger distance led to a more abstract representation of the decision. This can be explained in terms of high-level construals enabling people to traverse psychological distance. So that high-level abstract representation remains constant over a range of psychological distances. And I think we can use this to build path-finding frameworks for humans in urban areas. So here's a rough sketch of the framework. We've got the street level here with the pedestrian who's got visual perception of the immediate environment, and we want to match that up with the neighbourhood environment there, where a pedestrian relies on a cognitive map of the environment. So we've got three levels of route choice in this hierarchical framework: a strategic choice that's based on the road network, that's the most abstract level; a tactical choice based on a pavement network, which is a more detailed spatial representation, but spatially bounded; and then the most immediate operational choice, which is based on a continuous street environment, where the agent has knowledge of the other road users, their positions and velocities. And as well as having feedback from the upper levels to the lower levels, those decisions that are made at the higher levels then get revised at the lower level, because that's when those decisions must actually get enacted by the agents. So there's this kind of two-way feedback going on. Can I play a video? Is that going to happen? I wonder what's going to happen. Oh, great. Okay, there we go. Okay, so we run this for a neighbourhood, but here's just what's going on one street. We've got two scenarios here played on top of one another. Agents are moving from an origin to a destination. In red, we've got a high vehicle flow scenario. Those pedestrians are experiencing high vehicle flows. And in blue, low vehicle flows. We can see that the red agents tend to use the crossing infrastructure. But these agents have the same parameters and they perceive the same network link weights. So this difference in route choice is driven by their immediate perception of their environment that's then feeding up to higher spatial scales. Okay, and I think this is a useful framework that I'm using to model simulations over larger spatial areas. That's it. Thanks very much.